Hello everyone, welcome to the Environment Technology NewsHour. This is a weekly program on the environment technology. Sawadee krap, namaste, welcome you all for this program. As you know, this program is owned and managed by Technobiz, based in the company. Technobiz is based in Thailand. Let me give you some intro to the Technobiz. Technobiz is established in 2005 and recognized as International Resource Center for Industries and Technologies. We have foundation of this business foundation based on the professional education and also the business services and events. When it comes to the activities, what we offer, services we offer is we offer trade shows, trade exhibitions. We organize training programs and conferences. We have webinars, we have business networks, we have publications. We also do technical consulting and integrated marketing for the clients and the NewsHour like today. Our business segment, the way the segments of the industry we focus is there are two types, one on the focus on the polymer industry, rubber, plastics, polyurethane, adhesive coatings, and also the process technology focused on the chemical engineering and technology, energy and environmental, membranes and water membranes, filtration separation, and also the advanced material. These are our business focuses. And we cover all, I know our services are global. We offer these programs in all over the world. So welcome you all for this episode number 6 on the Environment Technology NewsHour. Today, our subject is focusing on in this presentation today is on the direct sludge to sludge heat recovery in wastewater treatment plants. We have a guest expert is Mr. Erwin Squash. He is the president of the Ddi Heat Exchangers and Energy Recovery Solution. He has extensive experience for last 22 years. He's involved with manufacturing of the heat exchange and heat recovery, particularly in the liquids with a high percent of solids. So, Mr. Erwin, welcome to the program today. And I'd like to invite you to make a presentation on the direct sludge to sludge heat recovery in wastewater treatment plants.
Thank you very much. First, is my screen shared? No, I have to show my screen. One moment, too many screens here. Do you see my screen now?
Not yet. Okay, I see the screen, but not the PowerPoint. Yeah.
Not the PowerPoint?
No.
Okay, send me the link again. Sorry.
Yeah.
There are 10 options there. Okay, this will be the right one because it flickered.
Yes. Okay, good to go.
Okay, thank you very much for willing to hear and know more about our unique patented Canadian technology. I'm not going to be very long, about 20 minutes or so, and then will be question and answers. Also, before I forget, I have 2 points I would like to bring up. I will be exhibiting in the IFAD show in Munich, Germany in the end of this year under the Canadian Pavilion. So feel free to drop by and meet me or ask whatever, anything you want. And also in our opening web page on the website, there are a few other videos there. One video is the, I don't know, like 30 minutes. I gave training to one of my representatives. Also, there's a 10 minutes there where I was on the Canadian Dragon Den, which is like the American Shark Tank. And I believe every country almost has something like that, where very rich people listening to suggestions or ideas by investors, by inventor, and then they decide if to invest in them. I had 4 out of 5 of those people interested in my company, but it's a long story. But anyhow, watch the video, it's only 10 minutes. So start. Basically, again, it's a very unique type of equipment, very different. And my goal here is to show you and to prove to you that our technology is so different that we are the only one in the whole world that actually can have direct sludge to sludge, heating or cooling, and energy recovery, and nobody else can do it. And I will talk briefly about the competition, and I also will bring up some point about other products we have, which are not the subject of this meeting today. So today thing is about our unique rectangular heat exchanger. We can do water to sludge like everybody else, but much less maintenance. I'll talk about it a little bit. And mainly the key thing, the key subject of today is direct sludge to sludge heat recovery. Basically, hot sludge moves the energy to the cold sludge. Different markets, wastewater treatment facilities is my main market. We have sample of molasses farms, industrials, hotel, laundry, etc., etc. And the way I see it is, we should approach the consulting engineers so they will be able to sell to their own customers the new product, the new technology, and the new energy, especially these days when cost of energy is up to the roof. I have another product, which I will not talk about it. We call it city sewage heat recovery, basically to take the city sewage, the sewage that goes under the ground, under the city, under the street, and to bring in and take heat from it in the winter and coolant from it in the summer, but it's not the subject of today. And basically, that's the way we take the city sewage and we bring it into our heat exchanger and we recover energy from it. I'll skip on that. That's the way it looks, the heat exchanger, the heat pumps, and the whole construction. We have another market, what we call the gray water, black water recovery. Basically, in big hotels or big buildings, when people take shower or toilet or whatever, and that heat is wasted because the hot water goes down, we can take that hot water, toilet and everything, no need to separate, and can go to our heat exchanger and we move the energy by preheating the cold water coming from underground before it goes to the boiler. So it's also a very good marketing tool to the big hotels or big industries to say we're doing energy recovery. We can sell it as a kit with the heat pump and the heat exchanger, everything as one nice kit. And we can do it because other technologies cannot do double wall, but I'll skip that for today. So let's start to talk about the main subject of today. And the way I see it, this is the main slide, the main information. So I'll take a drink because, it's a little bit longer. Basically, in wastewater treatment, we have what's called the digester. The digester is a big container where they heat and they keep the sludge inside in wastewater treatment, which is good for municipalities and for farms. Basically, anybody who does anaerobic digestion. I'm sure you guys know there is a mesophilic where they go not very high temperature, but long time, up to 20 days, 30 days. Then they got thermophilic, where they go, like only 10 days, but hotter temperature. Then they have pasteurization when they go very, very high temperatures, but only 40 minutes, 50, 60 minutes. So what happens is in this digester, doesn't matter if it's 30 days, 20 days, 10 days, or 1 hour, normally, usually, the hot digested sludge goes out and it's being wasted. What a waste. And it goes to the river or ocean, they dump it. By the way, the law changed in North America. They cannot dump any more hot digested sludge to the river or ocean because it kills or hurts the fish. So they actually have to cool it down. I repeat, they have to cool it down by law in North America. Also, the whole world is moving into this digestion, what's called Class A biosolid, whereby they heat it hot enough, long enough, and then they can use the wastewater after the digestion as a fertilizer to the farmers, and they call it Class A biosolid. But what happens is that sludge coming out minimum 35 degrees at mesophilic, or 55 degrees C at thermophilic, or 70 degrees C at pasteurization, it comes out and it's wasted. Why to waste it? Well, the reason the world is wasting it because they don't have heat exchanger that can do sludge in both sides, but we do. So we take that hot digested sludge into our heat exchanger on one side. You see, comes in digested sludge comes in, which is hot, 35, 55, or 72 degrees C. On the other side, we have the cold raw sludge, the unprocessed sludge, comes into the plant. And normally North America is very cold, it's 10 to 15 degrees C. In Asia is probably hotter, like 20, 25 degrees C, but still, there's quite big difference, even if it's 20 to 35, or even it's 25 to 35 degrees C, there's still 10 to 20 degrees difference, which we could, and we do, recover. So what happens is, let's take an average in the world, you know, about 20 degrees C coming in, 35 on the other side. So we heat it up from 20, the average is somewhere in between. Let's say we heat it up from 20 to 27, easier to calculate, let's say to 30 degrees C. And then we have another heat exchanger, which is water to sludge. And we increase the temperature from the 30 degree to 35 that they need, or 55 or 70. And we call it trim. Actually, we can put these two heat exchangers, one on top of the other to save on space. And then this heat exchanger, which is the common one in the world, which has recirculating sludge from the digester in and out, in and out, in and out. And the sludge comes in. Now the sludge comes in is not 20 degrees C, it's already 30 degrees C. So we only need to heat it from 30 to 35, let's say, on mesophilic. So this heat exchanger is smaller, the boiler is smaller, and the key thing is the energy required is smaller. So this sludge-to-sludge heat recovery, again, I repeat it, I know 4 times, but this is the only one in the world that can do direct sludge-to-sludge heat recovery, and that's the purpose of today for me to explain it. The return on investment is about 7-8 months, and if you add the cost of engineering and installation and all that, it's less than 1 year. And then the boiler is smaller, the water-to-sludge heat exchanger is smaller, so everybody is happy. Next. What's special about this Ddi heat exchanger? Well, we're not round, we are not spiral, we're really rectangular. And this is my second important slide, and I'll dwell on it also a little bit. Basically, there are 5 advantages having rectangular channel. I control the height of the channel, so nothing ever gets plugged. So we go 2, 3, 4 inch, not like the spiral who only has 1 inch. Our competition, the spiral technology, only has 1 inch. We go 2, 3, 4, 5 inch, so nothing ever gets plugged. We even had 26%. It's not an error, not 2.6. It's 26% solid, did not get plugged. Number 1, I control the height. Number 2, I control the width. And it's very important because we want to have a fast flow in order to avoid baking or plugging. Therefore, I control the width and we make the flow that's given to us to be very fast, so no baking to the surface. The third thing is when the flow goes from layer 1 to 3 to 5, in other words, it's hot, cold, hot, cold. So when the flow goes from layer 1 to 3 to 5, look what happens. The flow goes 90 degree out, 90 degree up, 90 degree in, and 90 degree in the direction of the flow. It's 4 times mixing, 4 times fast flow, and that really, really helps by having higher turbulence and better heat transfer. Also, as you can see, it's very compact, and therefore it's a very unique, the only one in the world that can have sludge to sludge. Also, if anything gets plugged, I'll show it to you after. It takes minutes to open because of this unique technology. Now I'll try to put in a video here. Let's see if it will work. And I run it. And let's see if it works. And where do we press to start?
Although it's the last place you'd want to be in, wastewater isn't useless. Introducing new patented technology by Ddi Heat Exchanger. experience proves the value of our technology.
By the way, this video is on our opening page of our website, so you can always see it anytime you want. Why other technologies cannot do it? The most common one that everyone knows in the whole world is the tube and tube or tube and shell technology. You see, we need to have fast flow and we need to have both a big gap, big spacing. So when you need to have both, also big gap and also fast flow, yes, they can have it in the blue in the middle pipe. They can have it 3-inch here, no problem. And they can have relatively fast flow, no problem. But if they want to have the same 3-inch gap also on the shell, on the outside, even visually you can see this whatever orange color becomes very, very big. So if the flow coming into the plant equals the flow going out from the plant, in other words, the flow in the blue and the flow in the orange is the same flow, you will see that the flow in this orange will be very, very slow. And since the flow is slow, it will bake and it will stick to the surface. And for that reason, the tube and tube manufacturer, if they're honest, they will tell you, no, we cannot have sludge to sludge. We can only have sludge to water. Also, when they put this tube and tube side by side, you can see how much space is wasted. That's why it's so big. The heat transfer of the tube and tube is around the center pipe, center tube. Our heat transfer is the full top of the layer plus the full bottom of the layer. So even visually, you can see that the overall length, the length of the top plus the length of the bottom is much more than the round tube. So for the same flow area, we have much bigger heat transfer area, which is very important for heat exchangers. For those reasons, our Ddi heat exchanger is relatively small, about 9 foot, and we need only for cleaning, and I will explain to it, about 2.5, 3 feet on each side, 1 meter on each side. While the tube and shell is about 20 foot, about 7 meter, and in another 7 meter, 20 foot for cleaning. This is kind of a summary. You can see how compact it is. Of course, like everybody else, a counterflow. And basically, we have here the flow going outside the bands. It increases the turbulence, very compact, hot, cold, hot, cold. Another competition, another technology I'm sure you guys are familiar with, is called the spiral. And that one, physically, it's not possible to make more than 1-inch gap and remove the pins. So if they try to remove the pins, they only have 1-inch gap. And for wastewater treatment, it's not good enough. It's only good for maybe 1 or 2 or 3% solid. It's not good for 4 or 5, 6%, and definitely not good as up to the 26% solid we had. And on the other side, where the water is, they must have pins, otherwise everything collapses. And there is no way they can have sludge to sludge. It's physically not possible. So basically, we can have the same flow in both sides. The competition cannot. We also can do cogeneration. We compare to cogeneration, and it is a study done by Brown and Colwell, Black and Rich, one of them, and showed that we are like 5 times more efficient than cogeneration, but I'm not going to talk too much about that. One of the engineering firms asked us to open how it looks inside after 8.5 years. The channel inside was clean, no damage because of the fast flow. If somebody ever wants to open inside, or if something ever gets plugged inside, we have what we call ECPS, Easy Cleaning Port System. It literally takes minutes, no doors, no gaskets. It literally takes minutes to twist it open and clean inside, 2 channels at a time. And then you can clean it with a simple plumber tool, turn it inside and clean inside if ever required. And we have 54 installations, mainly North America. And as far as we know, none of them ever got plugged. We have also a peak cleaning possibility to clean inside, never needed. Very quick summary, we are equal in price. We manufacture in Canada, India, and Mexico, and we are equal in price to the spiral or the tube and tube, never mind all the advantages that we have, and never mind that they cannot do sludge to sludge. But also, if it's water to sludge, we do not have the maintenance that they have. And if you add up, and you can download all these flyers from our website, we have a section downloads, you will see that they have to spend in 20 years like $450,000 for maintenance and cleaning, which we don't need to. I'm not going to dwell on that, but some people try to do the direct, they admit that they cannot do sludge to sludge, so they do sludge to water, water to water, water to sludge, which is crazy. They have 2 heat exchangers and we only need 1, and they lose heat transfer twice, we only lose once. The return on investment is less than 1 year, really about 8 months, and it's less than 1 year, including the installation cost, engineering cost, and piping cost. A quick sample, a small heat exchanger with 800,000 BTU per hour, let's say costs 129,000 US these days. You know, prices go up with the cost of energy and the cost of metal. And basically, you see, in 15 years, a wastewater treatment plant or any plant farm that does anaerobic digestion can save $5 million. We give a full spec, so we work with the engineers and we consider everything from viscosity and the full data. Many references. If you go to our website, you will see also the 26% solids. Also, you will see like 12 years sludge to sludge never got plugged. 70, it's not percent solid, but it's brick, B-R-I-K, of solids for the molasses world did not get plugged. We also can supply a Parker boiler. We can supply, if somebody wants a package deal with the boiler, made in USA Parker boiler, or the made in Germany Vogelsang or Berger pump. Many references with pictures, etc. Here, when we combined our heat exchanger with the Parker boiler, we put it on top, even though we prefer to put it side by side. Look at this reference, sludge to sludge, 13 years, never got plugged. 13 years, sludge in both sides, never got plugged. This is one of the big heat exchangers. You see a person here, very big. Here's the molasses, 65 to 70 brick, never got plugged. By the way, before that, they used tube and tube, and it got plugged every 3 or 4 months. I repeat, every 3 or 4 months. Then they used ours for 12 years, never got plugged. Look how thick is the molasses. That's me when I had more hair. And basically, the reason I'm showing it is because somebody can put the heat exchanger outside, of course, better to cover it. And what you can see here is 2-in-1. And I think it's very important. You can put the sludge to sludge heat recovery at the bottom, and then you put on the top the trim, keep on heating the preheated sludge with hot water, the temperatures you need. Basically, both heat exchangers in one frame saves a lot of space and much more efficient, and you can put outside. Again, more references. I find this one funny. This is a guy that used to have his heat exchanger plugged every 3 or 4 months. It has not shown any trouble. I check it and smile at it every month or 2. Shows no leaks, no pressure buildup, and no loss of efficiency. We also developed, but it's not the subject of today, a full pasteurization system. We installed it in the city of Tulsa, Oklahoma, with many references. These 2 big heat exchangers do sludge to sludge heat recovery. And then there's 2 in the back trim that they keep on heating it to the very high pasteurized temperature of 70 degrees C. And here 2 little ones, they put them one on top of another. They need to cool it because for the process and also by law. And that's the way it looks. Another project with the 11 heat exchangers outdoor in California. References from California with a 26% solid. We even can do tube and tube. A little funny story, we shipped it to the States. The Americans thought that we are sending a rocket. It was a real problem to pass the customs in the States. Many articles all over the newspapers and articles, some of them on our websites. This one is in Vancouver, and we just got a very big order from the city of Vancouver via Acciona in Spain, and we shipped them 5 heat exchangers. This one is one of the little ones in Vancouver that was shipped a few years ago. These are the new ones, and many references. I'm not going to dwell on that. This is a flyer. You can download basically the summary. This is an article, and here's we can dump or pull or push or lift the heat exchanger into a hatch. In other words, we can design it, it fits to the room and area you have. More references. You can download from our website and do your own return on investment calculation. You see, for sludge to sludge heat recovery, depends how big is the plant, is a return on investment is 0.8 of a year, less than a year. And if it's a very small plant, it's 1.2 years. That's the gray water, which is the other subject we talked about. This is the flyer that we have, you can download. This is again mentioning the gray water. This one, the most important one, wastewater treatment. This is the underground sewage. And this is kind of the last picture. We came out with a product, whatever marketing tool, if you want to call it. We call it We Buy Your Waste. If the wastewater treatment plant is big, we're willing to give the heat exchanger for free. I repeat, no capital cost to the customer. We give it for free. But we share the energy recovered, whereby the engineer or the consulting engineer or my rep takes 10%, the city keeps 30 to 40%, and I keep the 50%. And basically it can go on like 15, 20 years. So the customer does not take any risk, doesn't pay any capital cost, but they do the installation. I'm not going to go to all kinds of different countries to do the installation. And this is a view of how it looks inside. You can see it in our show if you come to IFAT Munich, Germany. You see the flow, let's say, of the sludge comes in, goes very long, 12 foot or 15 foot, turns around, and then goes the 90-degree out, 90-degree down, 90-degree in. And if ever anything gets plugged, this ECPS cleaning port takes minutes. You twist it open, you clean. Inside, we are going to this side or going to that side. So in this case, we have sludge and water in between, and sludge on the other side, exactly the same. The pasteurization system, we're not going to talk about. This one, to a little funny thing. These are some famous people I met in my life. Some of them only for a minute, some of them for much longer talk, and some of them very famous. I don't know if you know them, but I don't know. The husband of Oprah, Sylvester Stallone, Al Pacino. So that's what it is. That's pasteurization. We're not going to talk about that today. And I am finished. I am done. And I'm ready for questions or answers. How long it was? It was half an hour.
Thank you, Erwin. Thank you very much. It's an interesting presentation, and I think you have given excellent case studies of various, your cases of the, I think the references from various companies. I'd like to touch a little bit. I have a couple of questions to address, and the participants also can post any questions they have. First of all, is there any requirement on the percentage of solids? Any limitations are there? Any, is whether very concentrated or very, dilute? Can you talk about percentage solids to use in your system?
Peram, it's a very good question, and I did not ask you to ask it, but it's a very good question. In wastewater treatment facilities, normally the sludge comes in is about 8–9% solids. And then the digested one is 2 or 3 or 4% solid. Our competition cannot do the cold raw sludge 8–9% solid. I have some wastewater treatment like in farm, we just shipped a few months ago. They are using about 12 to 14% solid. And as you can see on the one of the references there, in California, they even had 26% solid. So we can do high percent solid that nobody else in the world can do. Of course, higher the percent of solid, higher the pressure drop.
Okay. And you mentioned about the, you have installed at least 50 plus installations, right? And I'm pleased to see that, some of them 13 years, no problems at all. That's great. But are there any challenges while implementing, projects? What kind of experience you have with your clients? You have installed in Canada, somewhere in India, I think somewhere in Mexico, yeah?
Well, it's a very unique design. It looks in theory very simple, channels, but it's very complicated to build and design. And that's why, not only because of price and not only because of loyalty to my fabricators in India or in Mexico and Canada, but it takes a lot of time with the learning curve of somebody to actually manufacture it and learn it. And obviously, patent or no patent, yes, we have patent, but we try not to show everything. But each project is different in a sense of particularly designed to the flows and temperatures and pressure drops that they have. But we have what we call, modular systems, where our design is from 2 feet to 20 foot, from 3 layers to 24 layers. So we have a modular design, but each project is very different.
You have mentioned one interesting way of doing your business. You can invest. You don't need to spend any money, but you can invest and also sharing the benefits out of it.
We buy your waste. It's called we buy your waste.
You buy your waste, and of course, I understand there is a formula for you, 50% and 30% and 20%. There is a formula for sharing the benefits based on the savings you gained out of this system. Can you talk about how many projects you implemented and where did they implement it?
Unfortunately, nothing yet. We just came out with it about a year ago, and it's very complicated with the municipalities because they're not allowed to get nothing for free. And giving them for free a heat exchanger is not legal in North America. So we have to find a complicated way whereby they rent it from a company. But we're working on it. And basically what we are trying to do is by renting it to them. But look, they're not stupid, the wastewater treatment facilities. Once they realize that they can do so much saving, they'll simply go and buy it. But it's possible if the plant is small and doesn't want to waste capital costs or doesn't want to take any risk, then we can share it. But we're working on it. And basically, I like the idea because then instead of having, 1 or 2 years, by the time they pay and all that, 1 year, this way we're going to have income for the next 15, 20 years. But no, we did not have it yet, but it's a beginning. Also, one of the reasons I came out with it is when I was with the Dragon Den, like the Shark Tank, I can use their money for the capital cost.
And you have, I think you have done most of the projects in the municipalities or industry projects also there.
You got cut. Can you repeat?
Municipal wastewater treatments or an industry?
Well, most of our business.
Is it all?
Most of our business is wastewater.
I'm referring to. Yeah. Okay. Let me complete it. Let me complete. See, there are of course wastewater treatment. There are 2 types of, right? Municipal wastewater, industrial wastewater, right? Do you have any projects in industrial wastewater treatment systems?
No, I don't know about industrial wastewater treatment. In North America, at least, even industrial companies, when they move or push their sludge, they shove it to the municipal, and the municipal takes the house wastewater treatment, the buildings, and they also take the industrial. In North America, at least, it's all combined. And for us, it's the same. It's called the municipal, and it comes from the industry, and it comes from the private homes. Our main business is wastewater treatment, but we're starting now in the market of farms because, I don't know, in North America, let's say there are 10,000 wastewater treatment facilities that do anaerobic heating, anaerobic digestion, but there are 100,000 of farms that do anaerobic digestion, cows, manure,
Yeah.
and all that. And we got one already and we installed, and we have a reference from them. And now we'll start to concentrate on that, because with municipal, it's very complicated. They go on tender, can take 5 years. You can lose it for $1. It's very complicated. In the farms, you just talk to the consulting engineer and to the farm owner, and there you go. So we have an installation, we have reference from them, and we're really looking to get into. That's one of the reasons we're going to IFAT Munich, Germany. In Europe, there are a lot of farms that do anaerobic digestion. I don't know about in the Far East, are they? I think so too. I heard in China, there were like 100,000 wastewater treatments that do anaerobic digestion, but I never managed to get there.
Well, I can tell you one case study for you. In Southeast Asia, palm oil. You know the word palm oil? Yeah, palm oil. Okay, it's like a vegetable oil. Yeah? You have palms, oil palms, and so you sterilize it, you digest, you get oil, and you use it in the soaps or in the food, various as a cooking oil as well. We have like a crude palm oil industry where they have the wastewater temperatures, you get like 60 degrees because they use a lot of steam. Okay? Before it goes to the waste anaerobic systems, it's the wastewater has very high temperatures. I think the systems like this in Thailand or in Malaysia or Indonesia, huge number of palm oil factories are there where they waste their energy a lot. Okay, of course they have plenty of other resources. They have a biomass. They have a lot of resources there. The government is giving an opportunity to utilize the waste heat recovery, whether you are using the cogeneration systems or all packaged, because you have a biogas, you have a biomass there in palm oil industry, and so the multiple options are there. But I always see that lot of heat being wasted because it's going to open ponds first before it goes to the anaerobic systems. Personally, I work in the palm oil industry in my early career, and now I realize that this heat exchange systems, it can really bring value, into the company like palm oil. So I would like to look into this palm oil industries where they have a wastewater temperatures are 60 plus, at 60, and also what happens if there is oil content in the wastewater? Does it cause any trouble? Because in palm oil industry, wastewater, it contains oil content, high oil content. How is going to be if there is oil content in the wastewater? Does it going to affect you? You have a solids, you have oil, you have high temperature, heavy solids, because there are a lot of fibers, and you can't squeeze all on the fruit. There is a lot of fibers also there. Okay, does your system can accept other than solids if there is oil content? How is it going to be?
First of all, Peran, we have to talk about it, you and me, after. Please get me into that market. I have no contacts, so I have no knowledge about it, number one. The answer is yes. Oil happens sometimes, but very rarely, and is basically being flows out. The same with the other liquid. And if anything, oil floats, so it goes up. So it simply just floats and goes out. It changes the viscosity, it changes the pressure drop. That's it.
Okay. Well, Erwin, before I let you go, just can you tell us, how you started this company for the benefit of all the people? You started almost 20 some plus years ago, and how is this journey for you? 20 so many years.
Now you tell to everybody how old I am. Not nice, but anyhow. Basically, I was working for some big companies, and I figured, what the hell, if I am good for them, let me work for myself. And then I had a business for 20 years in the computer business, but I don't know if you know, but the computer business went down the drain because the big companies squeezed the small companies. And I'm a mechanical engineer with MBA, and then somebody came to me and said, look, we have a spiral heat exchanger, We have tube and tube heat exchanger, which is one round and one spiral, and they get plugged all the time. Can you come up with an idea? We did an R&D, research and development. And then since I was not in that business, I was not in wastewater treatment, I didn't have to think like them of tube and tube or spiral. Said, what the hell, let's make it rectangular. And that's the way I found out that it's possible. And my company is for 22 years selling to wastewater treatment. There are a lot, as you say, there is, the market that you're saying we could touch. There's also a pulp and paper market. There is also a lot of heat exchangers on cruise boats. There's also a lot of heat exchangers on oil platforms. There's a lot of markets, but maybe one day somebody will buy me out and is going to go to all the other markets. Me being 22 years old, I can only concentrate for now on wastewater treatment. But if you want to get me into that other market that you talked about, Peram, let's talk about it after.
Sure. I mean, the heat recovery can happen in wastewater treatment systems where before going to a system, wherever there is a steam is used in the process, it comes into the wastewater, and not, of course, some of them, they have the condensate systems are there, but not really effective, but you still have temperatures like 40 degrees and sometimes 50, 60, I mean, I experienced 60 degrees also temperatures with, of course, there are various impurities. There are a lot of potential also there in industrial wastewater treatment system.
My gosh, even in the Far East, if you say 60 degrees C, the hot one, and even it's very hot there, and the coming in is around 30 degrees C, the difference is 30 degrees C difference. It's huge amount to recover.
But people use open pond systems because there is a land availability is there, and because you have to store it because of the control and the flow controls to the anaerobic systems. Of course, there are some issues, the practical issues all there. And there is something that you can, find a solution for these agro-based industries, particularly where they use steam as one of the process element in processing, which ends up in the wastewater as a heat, as a hot water, hot wastewater as well. Okay.
Not to confuse people, we are not efficient with steam or gas. We are really liquid to liquid.
Yeah. But we talk about wastewater with at high temperature, So
exactly.
Where basically you have a solid to solid, that's yeah. Okay, Erwin, thank you very much. Any final remarks to the audience? Would you like to share any final remarks? Thank you to the audience. Yeah.
Thank you very much, guys.
Okay, guys, that's the end of the presentation with Erwin Squash on the direct sludge to sludge heat recovery in wastewater treatment. Thank you once again, Erwin, for joining this session. You can always check this presentation on our YouTube channel, the Technology channel. Check it out. Okay. And if you need any information and assistance, you know how to reach us. Okay. This is our contact information. And I see you in next episode. Thank you all. Bye bye for now.